right, ladies and gentlemen, now that we know how to take care of a square root, we're now going to go through and solve bigger equations that have square roots or squares in them, or sometimes even a cube. So in order to do this, we're going to go through our steps. Our first 5 steps are exactly the same as what we had before. We have to first clear the parentheses. Then we're going to combine any like terms. Then we're going to get the variable to one side. We are going to cancel any adding or subtracting. We're going to cancel the coefficient. And our last step is to take, now I'm going to rewrite that. I'm going to write it different. We're going to cancel the exponent. And I'm writing it like that because this way, if it's a squared, then you have to do the square root. If it's a cube, then you have to do the cubed root. All right, so, and just like before, this is a big checklist. If I don't have it, then I don't have to worry about it. So let's see what we have going on here. So we have x to the third plus 9x equals half times 18x plus 54. So my first step is to clear my parentheses, right? We're using the distributive property. So I'm going to copy over x to the third plus 9x. Half of 18x is 9x. Half of 54 is 27. Okay, I don't have any like terms. I do have variables on both sides, so I have to move the 9x over to this side, or this one to this side. I'm actually going to move this one over because my goal is to try to get the variable that has the exponent by itself. Okay, so I'm going to cancel my 9x's, so x to the cubed, and these cancel, so I'm left with 27. I don't have a coefficient, I don't have anything else being added or subtracted, so now I have to get rid of that exponent, and that is supposed to be a 3. So now I'm going to take the cubed root of both sides. So I have to know, well, what times itself 3 times gives me 27? And our answer to that is a 3. All right, so very similar to what we've done before. We'll check a couple later on here. So here we go. For number 2, got to get rid of the parentheses first. So now when we do this, x times x is x squared. X times 3 is 3x. Minus 51 equals negative 3x plus 13. I do not have any like terms, so now I need to get the variables on one side. So I'm actually going to add 3x to both sides because my goal is to try to get my variable with the exponent by itself. So the 3x's are going to cancel and I'm left with 13. Now I have to cancel adding or subtracting, so I'm going to add 51 to both sides. So x squared, and this is going to give me 64. Hopefully I added that correctly. Now I have to cancel the exponent, so the opposite of squaring is to take the square root. And the square root of 64 is 8. Okay, so I know it looks a little bit harder because we have these squares or cubes in there, but it's not any different than what we've been working at. All right, a square has a side length of 3x and an area of 324. So again, when they're talking about shapes, we want to try to draw a picture. So I know my area is 324. I know my side is 3x. We want to know what's the value of x. Well, when I do these, right, we have 3x times 3x has to equal 324. Side times side has to give me the area. So when I do these, 3x, 3 times 3 is 9, x times x is x squared. So now I'm going to divide both sides by 9, right? So I have to get rid of my coefficient. So let's see, 3 goes into 20. 32. So I'm getting 26, I hope. Oh, x squared, sorry, forgot my x squared. And now I need to take the square root of that. Well, I can't take the square root of 26, it's not a perfect square, so we're going to just leave that. Let me just double check my math on that one. Oops, 324 divided by 9. Oh, hi, how about that should have been 36. Okay, so we'll ignore that. Good thing I checked. Okay, and then the square root of 36 is 6. Sorry about that. Hopefully you guys were all yelling because you knew. All right, try these. I want you to try these on your own. 2 problems, and then come back and see how you did. Okay, so going through number 4, I had to combine my like terms, so those actually canceled out because 5x minus 5x is 0. So then I added 14 to both sides, got x squared equals 81, had to take the square root, which was 9. So then I did my check, and you end up with 67 equals 67. For number 5, we had to subtract 14 from both sides, which gave me a negative 81, and then divided by negative 3, which was 27. And when you take the square root, you can't take the square root of 27. So if you did put it in your calculators, you could have said that x is about 5.2. You could have done that. All right, so a little bit of a lesson summary here. Equations that contain variables that are squared or cubed can be solved using the properties of equality and the definition of square and cube roots. Simplifying an equation until it is in the form x squared equals p or x cubed equals p. We talked about that. And then you take the square or cube root. So that's what we did. Any questions? As always, bring them to class. Have a good night.